In this problem, we have a 5-pound ball that is connected to a rigid rod with negligible mass, and it's pinned here. Let's call this point 0. Therefore, the rod with the ball can rotate about 0. It is released from rest, and it's subjected to force, which is a function of time, as well as a couple moment, which is also a function of time. We need to determine its speed at 5 seconds. The force always keep its direction that is perpendicular to the rod, and also the motion is in the horizontal plane, which is important hint that we do not need to consider weight. So if we do the force analysis of this rod, then we know that we will have support reactions OX and OY at 0. Therefore, the best way to solve this problem is to use the principle of angular impulse and momentum by summarizing the angular momentum and angular impulse about 0. Therefore, we do not have these unknown forces having moment about 0. They do not contribute to the angular momentum of this system at 0. So that's what we're going to do. Our equation will be HO1 plus the angular impulse during this time about 0, and that equals to HO2. So initially the ball is at rest, the system is at rest, therefore initially this term equals to 0. So we have this equals to this. We need to determine the total moment about 0, and that has two contributions. So if, again, following convention, counterclockwise is considered a positive. Therefore, we will have 0.5 times t squared, that is positive moment about 0. And the force right here is causing clockwise rotation about 0. Therefore, negative 0.2 t plus 2 multiplied by the moment arm of 3. And this right here is the total moment about 0. And if we integrate it with respect to time, from time equals to 0 to 5 seconds, and this term right here now is the total angular impulse to this system during this time frame about 0. And on the right hand side, that equals to basically the moment of linear momentum, which equals to m times v2 times the d, the moment arm. In this case, that will be the mass of the ball, which is 5 over 32.2 times v2, that's what we need to solve for, times the moment arm of 3 foot. So now this equation only has one unknown, which is v2. So on the left hand side, we can integrate this function of time with respect to time, and that will be a polynomial. So that will be 0.5 over 3 times 5 to the third power minus 0.3 times 5 to the second power minus 6 times 5. On the right hand side, that equals to 15 over 32.2 times v2. So from here we can solve for v2 to be negative 35.8 foot per second. The negative sign indicates that the final angular momentum is clockwise about 0. Therefore, in order for the ball to have clockwise angular momentum about 0, v2 must be vertical down.